Okay, welcome back. Today we're going to learn 4 new identities to go with our other 2. Alright, let's take a look at what they are. The first one says that if we find the sine of alpha plus beta, then that's the same as finding the sine of alpha times the cos of beta plus the cos of alpha times the sine of beta. And there's a very similar one which looks similar. It's alpha minus beta. Now, what we want to you need to learn these, all right? But what we want to try and help you learn them is that the sine formulas have a sine times a cos and a cos times a sine, but they keep the sign. In other words, that sign there is the same. So if we've got sine of alpha plus beta, then we've got a plus in the middle. If we've got sine of alpha minus beta, we've got a minus in the middle. The cos formulas, all right, so again we've got 2, one for alpha plus beta and one for alpha minus beta. They have 2 coses multiplied together and 2 sines multiplied together, but their signs change. So in other words, sine keeps the sign, the cos, the sign changes. If it's cos alpha plus beta, there's a minus here, and if it's cos alpha minus beta, there's a plus here. Okay, now these formulas kind of take a little bit of getting used to. Let's, in the first instance, just test one and just see if it actually makes any sense. All right, so I'm just going to go up here and I'm just going to do something like sine of 50 plus 12. So according to the formula, sine of 50 plus 12 will be the same as sine 50 times the cos of 12. Plus, remember, sine keeps the same sign, the cos of 50 times the sine of 12. Let's just test that out. Let's just get a calculator and see if that is in fact true. Okay, so on the left-hand side, obviously we've got sine of 62. Let's just work out what sine of 62 is. Sine of 62, 0,883. Okay, I'm just going to write that down just in case we forget it. 0,883. 0,883. Okay, now using our calculator, we're going to work the rest out. We're going to work out sine of 50 times by the cos of 12. And then we're going to add the cos of 50 times by the sine of 12. That's what our expansion says. And we get exactly the same number. Right, so these are facts. These are identities which are always true. Okay, now one of the things that you don't need to be able to prove them from scratch, but if you are given one of them, you need to be able to derive a formula for the other ones. Okay, and these are quite straightforward. We're going to go back to our all sine tan cos idea. So if we had sine of x minus y, so if we wanted to find an expression for sine of x minus y, and we had an expression for sine of x plus y, are we okay that sine of x minus y could be written as the same as sine? I'm just going to start slightly wider on this. I think we're going to need quite a lot of space here, so I'm going to start right up against the edge here. Sine of x minus y is exactly the same as the sine of x plus minus y. We okay with that? All right. Now, the reason I'm writing it like that is because that is what I've got this formula for. I've got a formula for sine of x plus something. So now I'm going to write this formula out, and wherever I see an x, I'm just going to leave an x. So I'm going to get sine x. And then the formula says cos of y. But now this is inside the bracket, so this is cos of minus y. All right, and then this is going to be plus the cos of x sine of minus y. Okay, now cos of minus y, think reduction formulae. We've got all sine tan cos. Cos of minus y, if we go a little bit into the 4th quadrant, in other words clockwise, cos is positive. So this actually becomes sine x cos y. go sine of minus y, so in other words, a fourth quadrant angle, it's actually negative. So this now becomes negative cos x sine y. And that there is the formula for sine of x minus y, which if we look kind of up at the top here, there it is, sine of x minus y. Notice we had alphas and betas, now we've got x's and y's. We're going to deal with all sorts of cases. Right, now the next one that we're going to look at is maybe slightly more interesting, because if we've got a formula for sine of something, how can we make a formula for cos of something? And the secret is we can write this as the sine of 90 minus x plus y using co-ratios. Okay, but we want to manipulate that into a formula which has got sine of something plus something. So what we're going to do now, we're going to write that as sine of 90 minus x plus y. And we're going to think of that 90 minus x as one thing and the plus y as the other thing. So now I want to show you how that looks in this formula. There's our x. That's the sine of the first thing, plus that is there. So sine, if we look at the formula, it says sine of something plus something. We find the sine of the first thing. So in other words, it's going to be sine of 90 minus x times the cos of the other thing, cos y. And there's going to be plus the cos of the other thing, the cos of 90 minus x, sorry, cos of 90 minus x times by the sine of y. Okay, and now if we now use our co-ratios again, sine of 90 minus x is cos, so we actually get cos x, cos y, plus just checking something here, cos x, cos y, sorry guys, this is 90 minus x, and this is in fact minus y. Right, so I've made a silly error here. This is a minus y, and then this is a minus over here as well, because I'm now using this this formula. Okay, and so I get cos x cos y minus sine x sine y, and that is the compound angle formula for cos of x plus y. There, I'll just scroll up and show you. There it is, cos of something plus something, cos minus sine sine. Okay, right, so we need to learn all of these and sort of make sense of them. Okay, let's now take a look at how we can use these. So how could we now calculate cos of 15 without a calculator? And remember, our special angles are 30 degrees, 45 degrees, and 60 degrees. So how can we make 15 with those numbers? Well, we've actually got two choices. We could either go cos 45 minus 30, or in fact we could go cos 60 minus 45. Let's do 45 minus 30. Now remember the formula, and we're going to scroll back up to the top just to show you. It's cos times cos, all right, and then a plus sine times sine. So have a look at this. It's going to be cos 45 times cos of 30, and then a plus sine of 45 times the sine of 30. Okay, now cos of 45 is root 2 over 2. That's a special angle. We can get it from the special triangles or from that fan. Cos of 30 is root 3 over 2. Sine of 45 is root 2 over 2. And sine of 30 is a half. Okay, so both of these fractions, when we multiply, we get quarters on the bottom. This one we get root 2 times root 3, which is the same as the square root of 6. This one we just get root 2. Both of them are over 4, so we can add them and put them all over 4. And there's our answer. Okay, let's just check that on a calculator. Our calculator is actually clever enough to do all that for us. If we work out the cos of 15, there it is. It's root 6 plus root 2 over 4. Okay, now we need to learn all these identities. We need to learn them kind of forwards and backwards. All right, so when we look at this, what is this? Which one of these things is it? Okay, I'm going to go back up there. Remember, the ones that go cos involve cos, and the sign is different in the brackets. The ones that go sine cos involve sine, and the sign is the same in the bracket. So let's look at this. Cos. This is a cos one. And this is in fact cos of 20 degrees. Now, because that's a minus, it'll be a plus for cos. Plus 10 degrees. So I'm jumping ahead of myself. 20 degrees plus 10 degrees. Cos 20 plus 10 is the same as cos 30. That's a special angle, and we can get that either from our fan or from our special triangles or even from our calculator. But we would expect to see the working in between. In other words, we wouldn't just expect you to go straight from here with your calculator. There's the answer. Okay, so we would expect you to change it to cos 30 first, and then like that. This one, sine cos. Now sine cos is the sine one. This is sine, and it's going to be 43. And then this is a plus, so it's going to be 43 plus 17. And 43 plus 17 is actually 60 degrees. So that is all the same as sine of 60 degrees. At the moment, we're just trying to get you used to these formulas. Okay? Do you know what sine of 60 is? Yeah, it's also root 3 over 2. Okay, we're going to ask you to pause the video, and we're going to ask you to try the rest of these, then let it play again and see how you went. Okay, so this one, sine 140 cos 30, this is a sine one. This is sine of 140 plus 130. And that's the same as the sine of 270. And remember that we can work out trig ratios on the axes either by thinking of a trig graph. Sine of 270. 270 is 3/4 of the way through. Sine of 270 is -1. That's the one way we can do it. The other way, remember, is that if we think of sine being y over r, right, if we pick a radius, let's say we go for a radius of 5. If that's 5, it will mark down on that y-axis to a point 0 minus 5. Now remember, sine is y over r, -5 over 5, we get -1. Okay, the next one, cos sine plus cos sine. This is definitely the sine one because it's got products of sines and coses. And we've got a plus sign here, so this is going to be sine of 14 plus 6. It's going to be the sine of 20 degrees. That's not a special angle, so we will just leave that one exactly as it is. The next one is a cos one. It's cos. No, it's not. Sorry, it's also sine cos. Okay, so it's sine 42 cos 12 minus cos 42 sine 12. This is in fact sine of 42 degrees minus 12 degrees. And that is sine of 30 degrees. That's a special angle. And sine of 30 degrees are half. Okay, the next one has got a negative in it. Let's take that negative out. So now we're going to get cos 80 cos 35 plus, because we're factoring out the negative, sine 80 sine 35. Right, and so we actually get negative. Now this is cos of 80 minus 35. This is cos of 80 minus 35. 80 minus 35 is 45 So our final answer here is negative cos of 45. And 45 is a special angle, negative root 2 over 2. Okay, and then the last one, this one has got sine, sine, and cos, cos. Now it's got a negative there. Our cos one actually starts with the coses. So let's take a negative out. Now it's going to be cos 55, cos 5, plus sine 55, no, sorry, that's right, sorry, it's going to be minus, we're going to need a minus here now, because we're factoring out a minus, it's going to be minus sine 55, sine 5. Okay, and so it's going to be the negative, now this is cos, and remember cos the sign changes, so this is going to be cos of 55 plus 5. So we're actually going to get negative cos of 60 degrees. And that's a special angle, cos of 60 is a half. Final answer, negative a half. Right, before the next lesson, try the questions on the next page, all right, and then we'll go over them next time. All right.